For this analysis, I'm going to show you how to use SPSS to conduct a one within repeated measure analysis. You notice that we are going to use the absentee data from your EDCI 502 one within repeated measures chapter from D2L. So we have 4 grading periods, and we have absentee, the number of days absent for 12 students across these grading periods. The idea here is we want to see if, because students were allowed to attend an alternative school that has a more flexible learning environment, we want to determine if their mean absentee days absent will decrease over the 4 grading periods. So in order to do this analysis, we go up to Analyze, General Linear Model, and then we go to Repeated Measures. And in this case, we have our within subject factor is grading period, or G period. And we have 4 levels. So this is just like a factor that we've done with factorial ANOVA, but we have 4 levels. And so we'll add and then define. Click on define. Now we can actually select all of these at once by hitting the shift key, and then we can move them into the within subjects variable box. For the outputs, what I like to have are the plots, and I like to have, when it's a one within, when there's just 4 levels, have the 4 levels of the factor on the horizontal axis. And so we can add and then go continue. And then we don't need to worry about a Posthoc test because we don't have a between subjects factor. So in other words, if we added gender in this between subjects factor box, then we would want to get the Posthoc tests to compare males and females. Of course, there again, we wouldn't get Posthoc tests anyway because males and females were only 2 levels. But let's just say we had father's education levels that had 3 different groups. Then the Posthoc test would be appropriate. So then we click on options. I like to put grading period in the display means area, and then the overall, which gives us our grand mean. Descriptive statistics, estimates of effect size, observed power, and homogeneity tests. These are the things that we typically add for any of our analysis. And then we go continue, and then OK. And you can see for our output, we see we have the 4 grading periods, and then across these 4 grading periods we have the means and the standard deviations, the average number of days absent for each grading period. Then we have the multivariate test, and we're going to skip that, and we're going to work our way down to the test of within subjects. That's the one that we'll want to use for this analysis. The next important piece of this output that we should look at is Mauchly's test. And Mauchly's test is similar to the Levine's test in the sense that it tells us if we have significant differences and variances between levels, and then if we have significant differences in variability within a level. And so we'll discuss this in more detail in class, but because we're violating that assumption, then we have to make sure that we interpret a corrected F ratio. And in this case, if Mauchly's test was not significant, we would just read the sphericity assumed line. But since it is significant, we can go down to this second line, read the greenhouse geyser correction, and so this analysis, or this particular calculation, allows us to be confident that we're not making a type 1 error when we say there's a significant decrease in mean absentee rates across those 4 grading periods. We're not going to worry about the within subject contrasts, and then we can see again, the mean and the means across the 4 grading periods. And then this is the grand mean, 3.771. And you can verify that by looking in your course pack. The output in terms of the graphic we get, we can see that this is the first grading period where we had over 4.5 days of average absentees, where we're going all the way down to now at the 4th grading period we have about 3. So that's a large drop. But this is the repeated measure, time 1, time 2, time 3, and time 4.